Welcome again, my dear students. This is the sixth and last time that we are here for trigonometry. This is the sixth lecture of trigonometry, and we are going to finish this trigonometry in this session. Okay, so without wasting your time, let's go to the slide. First of all, let's summarize the trigonometry part 5. In the last lecture, we have learned the following topics: examples on formulae for multiple and submultiple of angles. Then we have learned inverse trigonometric functions, the definition of inverse trigonometric functions and their properties. Then we have learned the formulae for minus x with proof and examples on the above two topics. Okay, so today we are going to continue that topic, inverse trigonometric function, and we are going to learn some new formulae. So the subtopic is formulae for 1 upon x. So first formula for 1 upon x is cosec inverse x equal to sine inverse 1 upon x. See, and the condition is mod x greater than or equal to 1. So for example, if cosec inverse 2, then we can write this is equal to sine inverse 1 by 2. Okay. Second one is sec inverse x equal to cos inverse 1 upon x. The condition is same, mod x greater than 1. So here, if sec inverse 3, then this is equal to cos inverse 1 by 3. The third one is cot inverse x equal to tan inverse 1 upon x if x greater than 0. Here for cot inverse x we have two formulae. If x greater than 0, then you can write directly tan inverse 1 upon x. For example, if cot inverse 5, then this is equal to tan inverse 1 by 5. And if x less than 0, means x is negative, then cot inverse x equal to pi plus tan inverse 1 upon x. Means suppose if cot inverse minus 5, then this is equal to pi plus tan inverse minus 1 upon 5. Okay. So these are the formulae for 1 upon x. These are very useful and important formulae. Okay. Let's prove the results. So the first result was cosec inverse x equal to sine inverse 1 upon x, where mod x greater than or equal to 1. Proof. Suppose cosec inverse x equal to theta. Now where is theta? So theta belongs to closed interval minus pi by 2 to plus pi by 2 minus 0. Therefore cosec theta equal to x. By the definition of inverse function, cosec inverse x equal to theta, then cosec theta equal to x. Now we all know that cosec theta is nothing but 1 upon sine theta. This is the reciprocal of sine theta. So sine theta is equal to 1 upon x. Okay. Now we want to take this sine on the right side, and it will become sine inverse. So therefore theta equal to sine inverse 1 upon x. But there is one condition. As mod x greater than or equal to 1 implies 1 upon mod x less or equal to 1. and that's why we can do this. Theta equal to sine inverse 1 upon x. But what is theta? See here, theta is cosec inverse x. So write down here cosec inverse x. So we have cosec inverse x equal to sine inverse 1 upon x. Thus we have proved the first result. Similarly, we can prove second and third result also. Okay. From the previous results, we can easily verify the following results. See, first one, sine inverse x equal to cosec inverse 1 upon x. See, before we have learned that cosec inverse x equal to sine inverse 1 upon x, and this time we have wrote sine inverse x equal to cosec inverse 1 upon x, where x belongs to closed interval minus 1 to 1 minus 0. We have to subtract this 0 because x cannot be 0. If x equal to 0, then 1 upon x is not defined. Okay, so minus 0 is necessary. For example, suppose sine inverse 1 by 2, and this is equal to cosec inverse 1 upon 1 by 2 means cosec inverse 2. Second, cos inverse x equal to sec inverse 1 upon x, where x belongs to closed interval minus 1 to 1 minus 0. Same as first. And the third one, we have two formulae, tan inverse x equal to cot inverse 1 upon x if x greater than 0. So if x greater than 0, tan inverse x equal to cot inverse 1 upon x, and if x less than 0, then tan inverse x equal to cot inverse 1 upon x minus pi. So these results are also very important, and this can be verified using the first three result. Okay, so note down this result in your notebook. Now, formulae for complementary numbers. Complementary numbers means કોટિકોણ કોટિકોણના માપ માટે આપણે કોટિકોણના જે ખૂણાઓ છે, કોટિકોણ એટલે જે બે ખૂણાઓનો સરવાળો 90 અંશ થાય, 90 degree. They are known as complementary angles. So let's learn some formulae for complementary numbers. First one is sine inverse x plus cos inverse x equal to pi by 2, where mod x less or equal to 1. See, this is pi by 2 is in radian, but in degree pi by 2 is equal to 90 degree. So sum of these two is 90. That's why this formula is known as complementary numbers. Okay. Now second one, cosec inverse x plus sec inverse x equal to pi by 2, where mod x greater than or equal to 1. Third one is tan inverse x plus cot inverse x is also equal to pi by 2, and where x belongs to r. So this formula is true for all real values of x. Okay, so these three formulae are known as complementary numbers, formulae for complementary numbers. These three results are very important, and we will use these results in examples to solve the examples. So let's prove the above results. First result, sine inverse x plus cos inverse x equal to pi by 2, where mod x less or equal to 1. So proof, suppose sine inverse x equal to theta, and what is theta? Theta belongs to closed interval minus pi by 2 to plus pi by 2. Okay, so by the definition of inverse function, we can write sine theta equal to x. Now we all know that cos of pi by 2 minus theta equal to sine theta. This is very known result for us. We have learned this result. Okay, cos pi by 2 minus theta equal to sine theta. But what is sine theta? Sine theta is equal to x. So instead of sine theta, write down x. So we have cos pi by 2 minus theta equal to x. Okay, remember this. Now we want to take cos on the right side and it will become cos inverse, but there is some condition needed. Pi by 2 minus theta must lie in minus pi by 2 to plus pi by 2. So before taking this cos on the right side, let's try to prove that pi by 2 minus theta lies in this interval. Okay, so we have given that minus pi by 2 less or equal to theta less or equal to pi by 2. This implies minus pi by 2 less or equal to minus theta less or equal to pi by 2. If theta lies between these two, then minus theta also lies between the same. Can you prove this? Try to prove this. Okay. Now add pi by 2 in this 3 part. So we have pi by 2 minus pi by 2 is 0. Then in middle part pi by 2 minus theta. And here pi by 2 plus pi by 2 is pi. Okay. So pi by 2 minus theta lies between 0 to pi. So cos pi by 2 minus theta equal to x implies pi by 2 minus theta equal to cos inverse x. Okay. Now what is theta? Theta is sine inverse x. So write down here instead of theta. So pi by 2 minus sine inverse x equal to cos inverse x. Now if you take a minus sine inverse x on the right side, we get sine inverse x plus cos inverse x equal to pi by 2. And hence we have proved this result of complementary numbers, sine inverse x plus cos inverse x equal to pi by 2. Similarly, we can prove the result 2 also. Now let's prove the result 3. Tan inverse x plus cot inverse x equal to pi by 2, where x belongs to R. So proof, the same proof is here. Suppose tan inverse x equal to theta, and where is theta? Theta belongs to open interval minus pi by 2 to plus pi by 2. Okay. Now by the definition of inverse function, tan inverse x equal to theta implies tan theta equal to x. Now we know that cot pi by 2 minus theta equal to tan theta. Okay. This is known result for us. We have learned this result before. So cot pi by 2 minus theta is equal to tan theta. But what is tan theta? Tan theta is equal to x. So instead of tan theta, write down x here. So we have cot pi by 2 minus theta equal to x. Okay. Now here also we want to take cot on the right side and it will become cot inverse. But we need some condition. Some condition must be satisfied. This pi by 2 minus theta must lie in 0 to pi. So first of all let's try to prove this. Here see here theta belongs to minus pi by 2 to pi by 2. So see here this is minus pi by 2 less than theta less than pi by 2. This implies again minus pi by 2 less than minus theta less than pi by 2. Now add pi by 2 in these 3 parts. So if we add here pi by 2, then pi by 2 minus pi by 2 is 0. Here we add pi by 2, then pi by 2 minus theta, and pi by 2 plus pi by 2 is pi. So we have 0 less than pi by 2 minus theta less than pi. Now we can take this cost on right side. So this implies pi by 2 minus theta equal to cot inverse x. Now what is theta? Theta is tan inverse x. So write down here. So pi by 2 minus tan inverse x equal to cot inverse x. Now if we take minus tan inverse x on right side, then we have the result tan inverse x plus cot inverse x equal to pi by 2. This is also very important result. Okay, so we have proved these two results for complementary numbers, and try to prove the second result also. Now let's learn some more formulae, addition and subtraction formulae. Okay, સરવાળા અને બાદબાકીના સૂત્રો. If x greater than 0 and y greater than 0, then means x and y are both positive, then the first result is tan inverse x plus tan inverse y equal to. But for tan inverse x plus tan inverse y we have three results and there are conditions. So if x into y is less than 1, product of xy is less than 1, then tan inverse x plus tan inverse y equal to tan inverse x plus y upon 1 minus xy. Tan inverse x plus tan inverse y equal to tan inverse x plus y upon 1 minus xy if xy less than 1. But if xy greater than 1, then what? Then tan inverse x plus tan inverse y equal to pi plus tan inverse x plus y upon 1 minus xy. See, if xy greater than 1, this condition is compulsory. X and y both are positive and x into y is greater than 1. Then tan inverse x plus tan inverse y equal to pi plus tan inverse x plus y upon 1 minus xy. And if x into y is equal to 1, then tan inverse x plus tan inverse y equal to pi by 2. So these three results are very important. We will use these results in our examples. These formulae are known as addition formulae. Okay, because this is tan inverse x plus tan inverse y. This is addition. So these formulae are known as addition formulae. So note down this formulae in your notebook and remember this condition also. Okay, we have, before using this formula we have to check these conditions. Now let's learn the second formula. If x greater than 0 and y greater than 0, then second formula for subtraction, tan inverse x minus tan inverse y, and here there is no condition. For any x and y real numbers, we have tan inverse x minus tan inverse y equal to tan inverse x minus y upon 1 plus xy. Okay, this is the formula known as subtraction formula. So we will also use this formula in our examples. We are not going to prove this formula. We will accept this formula without proof. Okay, so try to remember this formula. These are very important for you. Now, interrelation formula. Interrelation formula means आंतर संबंध सूत्रों, साइन इनवर्स, टेन इनवर्स, सेक इनवर्स, कॉस इनवर्स, कोसेक इनवर्स, आ बधा वच्चे एकबीजामां रूपांतरित करवा माटेना सूत्रों. Those formulae are known as interrelation formulae. So the first formula, if 0 less than x less than 1, this condition is necessary, x lies between 0 and 1, then sin inverse x equal to cos inverse square root 1 minus x square. If you want to convert sin inverse x in cos inverse, then you have to use this formula, sin inverse x equal to cos inverse square root 1 minus x square. If you want to convert sin inverse in tan inverse, then we have this, sin inverse x equal to tan inverse x upon square root 1 minus x square. Okay, so from sin inverse x, we have learned before that from sin inverse x we can convert this into cosec inverse 1 upon x. from sin inverse x we can convert this into cos inverse x, and from cos to sec inverse x also. Sin inverse x we can convert in tan inverse x, and from tan inverse to cot inverse also. So we can convert sin inverse x in all remaining 6 inverse trigonometric functions. Okay. Now second one, if x 0 less than x less than 1, then cos inverse x is equal to, we want to convert this cos inverse in sin inverse. So cos inverse x equal to sin inverse square root 1 minus x square. Same like this. Okay. Now if we want to convert cos inverse x in directly tan inverse, then we have this. Cos inverse x equal to tan inverse square root 1 minus x square upon x. Okay. So from cos inverse we can convert this function in remains 5 inverse trigonometric functions. Okay. Now last one, if x greater than 0 means x is positive, then tan inverse x equal to sin inverse x upon square root 1 minus x square. Or if we want to convert tan inverse in cos inverse, then tan inverse x equal to cos inverse 1 upon square root 1 plus x square. So these are interrelation formulae, and these are very important. So please note down in your notebook and try to remember this formulae, because we are going to use this formulae in our example. Okay. Now let's go to the examples, and this time we will use the teletop. So our first example is prove that tan inverse 1 by 2 plus tan inverse 1 by 3 equal to pi by 4. Prove that. Okay. Tan inverse 1 by 2 plus tan inverse 1 by 3 equal to pi by 4. So let's proof. Let's start with LHS. Our LHS equal to tan inverse 1 by 2 plus tan inverse 1 by 3. Now compare this LHS with tan inverse x plus tan inverse y. So here, what is x? X equal to 1 by 2. And what is y? Y equal to 1 by 3. But before we use the addition formula, we have to check the condition, because we have 3 formulae. So first of all, multiply this x into y. X into y is 1 by 2 into 1 by 3, which is 1 by 6, and 1 by 6 is less than 1. Okay, 1 by 6 is less than 1. So we have to use the first formula, tan inverse x plus tan inverse y equal to tan inverse x plus y upon 1 minus x into y. Okay, because x into y is less than 1. Now see here, this is 1 by 2 plus 1 by 3. So we have to take LCM. LCM is 2 into 3 is 6, and here also LCM is 2 into 3 is 6. So we have tan inverse 3 into 1 is 3 plus 2 into 1 is 2 upon 6, and this 2 into 3 is 6. 6 will be multiplied here, so 6 minus 1 upon 6. 6 will be cancelled out, so we have tan inverse 3 plus 2 is 5 upon 6 minus 1 is also 5. This is nothing but tan inverse 1. And what is tan inverse 1? Tan inverse 1 is nothing but pi by 4, which is our RHS, right hand side. So we have proved this result, tan inverse 1 by 2 plus tan inverse 1 by 3 equal to pi by 4. This is the proof. So before using this formula, because we have 3 formulae for this, so we have to check this condition. This condition we must have to check. Okay, I think you all can understand. Now let's go to the second example. Example number 2. Prove that tan inverse 2 by 3 plus tan inverse 10 by 11 plus tan inverse 1 by 4 equal to pi by 2. Let's try to prove this. So what is our LHS? Left hand side is tan inverse 2 by 3 plus tan inverse 10 by 11 plus tan inverse 1 by 4. Now here we have 3 terms to add, but we have addition formula for only 2 terms. So first of all, we are going to add this first 2 terms. We will add these 2 terms, but before applying the formula we have to check the condition. See, this is tan inverse x plus tan inverse y. Here x is 2 by 3 and y is 10 by 11. Okay, so therefore x into y is equal to 2 by 3 into 10 by 11 means 20 by 33, and clearly this is less than 1. This is less than 1, so we will use the first one. So tan inverse x plus tan inverse y equal to tan inverse. This is x means 2 by 3 plus y means 10 by 11 upon 1 minus x means 2 by 3 into y is 10 by 11. Okay, and plus this last term tan inverse 1 by 4. Now we have tan inverse. See here in the denominator this is 3 and 11, so we have to take LCM, and LCM is 3 into 11 is 33. So multiply 11 by 2, so we have 22 plus 3 into 10 is 30 upon 33. Okay, this whole upon 3 into 11 is 33, multiply by 1, so 33 minus 2 into 10 is 20 upon 33 plus this third term, write down as it is 1 by 4. Now this 33 will be cancelled out, so we have tan inverse. See, 22 plus 30 is 52 upon 33 minus 20 is 13 plus tan inverse 1 by 4. Now see here, 33 4s are 52, this is 4, so we have tan inverse 4 plus tan inverse 1 by 4. Okay, so our LHS become this, tan inverse 4 plus tan inverse 1 by 4. Now see, this is equal to, we have to use tan inverse x plus tan inverse y formula, but before we use, we have to check the condition. Here x equal to 4 and y equal to 1 by 4. Okay, now x into y is equal to 4 into 1 by 4, this is nothing but 1, so x into y is 1. So tan inverse x plus tan inverse y, if x into y is equal to 1, then tan inverse x plus tan inverse y equal to pi by 2. Thus we have proved this result. This is RHS. Okay, so we have proved this result. Now let's go to the example number 3. Third example is very beautiful. Prove that tan inverse 1 plus tan inverse 2 plus tan inverse 3 equal to pi. See, prove that. This third example, prove that tan inverse 1 plus tan inverse 2 plus tan inverse 3 equal to pi. So let's see, this looks very beautiful result. Let's try to prove this. LHS equal to tan inverse 1 plus tan inverse 2 plus tan inverse 3. Here also we have 3 terms, so first of all we will add these first 2 terms. Okay, so again we have to check the condition. What is x? X is 1, and what is y? Y is 2. Now x into y equal to 1 into 2 equal to 2, which is greater than 1. Okay, this is 1. So here which is greater than 1, so we have to use the second formula. Tan inverse x plus tan inverse y is pi plus tan inverse, this is x is 1 plus y is 2 upon 1 minus x into y, plus write down the third term as it is, tan inverse 3. Now this is equal to pi plus tan inverse 1 plus 2 is 3 upon 1 into 2 is 2 and 1 minus 2 is minus 1 plus tan inverse 3. This is equal to pi plus tan inverse minus 3. 3 upon minus 1 is minus 3 plus tan inverse 3. Now in the last lecture we have learned that tan inverse minus x equal to minus tan inverse x. So pi, this is tan inverse minus 3 is minus tan inverse 3 plus tan inverse 3. Tan minus tan inverse 3 and plus tan inverse 3 will be cancelled out. So we have LHS equal to R, which is RHS. This is our result. We required this pi and we have got this pi. Okay, so we have proved the third result. This is very beautiful result. Now let's go to the example number 4. Prove that tan inverse 3 by 4 plus sine inverse 4 by 5 equal to pi by 2. We want to prove this. Okay, so let's try to prove this. See here, first of all, this is tan inverse 3 by 4 plus sine inverse 4 by 5. We don't have such formulae to add tan inverse and sine inverse. We have the formulae for tan inverse x plus tan inverse y. So first of all, we have to convert this sine inverse in the form of tan inverse. Okay, so what is that formula? That formula is sine inverse x equal to tan inverse x upon square root 1 minus x square. Now using this formula, we have sine inverse 4 by 5. Here sine inverse 4 by 5, x is 4 by 5. So this is equal to tan inverse x means 4 by 5 upon square root 1 minus x square. Our x is 4 by 5, so x square is 16 by 25. Okay, this is equal to tan inverse 4 by 5 upon, take here LCM, so 25 minus 16 is 9, so square root 9 upon 25. Okay, therefore this is equal to tan inverse 4 by 5 upon, what is the square root of 9 upon 25? Square root of 9 is 3 and square root of 25 is 5. See here, tan inverse 4 by 5 upon 3 by 5. 5 will be cancelled out. So we have this is equal to tan inverse 4 by 3. So we have got that sine inverse 4 by 5 equal to tan inverse 4 by 3. Okay, now let's start with LHS. Our LHS is tan inverse 3 by 4 plus sine inverse 4 by 5. Now this is same as about tan inverse 3 by 4 plus sine inverse 4 by 5 is tan inverse 4 by 3. Use this result. Okay, so this is nothing but tan inverse 4 by 3. Now see, this is equal to, this is the form like tan inverse x plus tan inverse y. But what is x here? X is 3 by 4. And what is y? Y is 4 by 3. Now x into y is 3 by 4 into 4 by 3, which is 1. So x into y is 1. Okay. And so tan inverse 3 by 4 plus tan inverse 4 by 3 is nothing but pi by 2, which is RHS. So this is very important here, that we have convert this sin inverse x in tan inverse form. So we have used this formula here to convert, and then we have used tan inverse x plus tan inverse y form. Okay. So this is our fourth example. Now let's go to the fifth example. Prove that sine of cot inverse of tan of cos inverse x equal to x, where 0 less than x less than 1. See, very beautiful example. Prove that sine of cot inverse of tan of cos inverse x equal to x. So let's start with LHS. Our LHS is sine of cot inverse of tan of cos inverse x. Okay, so we will start simplifying from this inner side. Okay, from this, here the function is tan and here the function is cos inverse. So to remove this function, we have to convert this cos inverse in tan inverse form. So this is sine of cot inverse of tan of, now cos inverse x equal to tan inverse square root 1 minus x square upon x. We have just learned this formula, cos inverse x equal to tan inverse square root 1 minus x square upon x. This is interrelation formula. Now sine of cot inverse, now see this is tan and tan inverse, tan of tan inverse x equal to x. So we have this square root 1 minus x square upon x. Tan inverse x equal to x, we have used that formula. Now we have this result, sine of cot inverse square root 1 minus x square upon x. Now remove this sine and cot inverse. We have to convert this cot inverse in the form of sine inverse. So we cannot directly convert this cot inverse in sine inverse, but first we have to convert this cot inverse in tan inverse. So this is sine cot inverse x equal to tan inverse 1 upon x. So this is tan inverse x upon square root 1 minus x square. Okay, sine of tan inverse x upon 1 minus x square. This is cot inverse square root 1 minus x square upon x. Cot inverse x equal to tan inverse 1 upon x. So we have this. Now this tan inverse, we have to convert this tan inverse in sine inverse form. What is the formula to convert this? The formula is this one. Tan inverse x equal to sine inverse x upon square root 1 plus x square. We have to use this formula. Here this x is this part. See, this is our x. So sine of sine inverse tan inverse x, then sine inverse x is here. This is our x. So we have to write this x in numerator, x upon square root 1 minus x square upon square root 1 plus x square. So square root 1 plus x square means square of this, square of this, square of x is x square upon square of this part is 1 minus x square. Okay. Now this is sine of sine inverse x upon square root 1 minus x square upon, if you take LCM, 1 minus x square plus x square, then x square will be cancelled out. So 1 upon square root 1 minus x square. This 1 minus x square, 1 minus x square will be cancelled out, and so we have sine of sine inverse x upon 1 is x, and this is nothing but x, which is the required result, which is RHS. So we have proved this result. I hope you have enjoyed the lecture series of this topic. I hope that these lectures will useful to learn trigonometry. Thank you very much.